Okay, let's adjust this accordingly. Oh well, I don't have to do. Back it up a little. Give it another 2 minutes, 2 or 3 minutes before we get started. Okay, would you go ahead and pull the door? Not shut, but like crack it. Yeah. Okay. So before we get started, we're going to do a little housekeeping before we get going. All right. So we are a lab behind. I will be posting that this week. It will be very simple. I'm going to. There is a lecture on it. And we will be doing, I am actually going to teach today the lab that we were supposed to do last week. And then lab 5 will go up very soon. And that will be, I'm going to simplify it a little bit so that we can get it done. I believe, and I'm not trying to panic anyone, I believe, I just looked at the academic calendar, I think next week is midterms. I need to double check that. I am of a 90% certainty that that is the case. That being said, I am going to, something that I have done for all of my classes previous to this, is I am going to hold a study session. And this study session is typically, well, before Rona was done in person, and was something that I tried to do to help round out any knowledge that you may feel you need reinforced, okay? So the way we're gonna do it this year is I'm probably either going to set up, I don't really care for Teams, maybe Zoom, or we might do a YouTube stream. And it will be exactly what I'm doing here. It will be some of you at home who will be able to watch me as I'm explaining things, and you will be able to ask me any question you like through this. And I will go through it. I will help step you through it. Any of the labs we have done, I will help you get through. Okay. Just to reinforce this a little bit. So these study sessions, and for those of you watching at home, I also want you to hear this as well. These study sessions have benefited the students that have shown up to them and attended them and brought questions to them. And I found last year, when I looked at the grades of those who showed up to the sessions and those who didn't, I was curious the impact that these were having. The people who showed up to the study sessions, scored 12% better on average. 12% is an entire letter grade. And I can say for a certainty that none of you will fail if you come to the study session. Because I will answer any question you have. I will step through it. We will go through it, and I will make sure that you understand the process, that you understand the material that I have been teaching. So here's what I want you to do. If you show up to the study session, bring a question. You bring 5, I don't care. Bring a question. And you are free to ask it. And I will step through. Now I feel like since there are 30 geology students here, we will most likely have a lot of overlap. But show up with a question. Ask me something. Don't be afraid. Even if it's something that you feel you might have an okay handle on, but maybe there's like 1 or 2 facets of it you don't get, don't be afraid to say something. Because we are going to get through this semester together since it's kind of a strange semester. So I want to be sure that all of you have the best chance at doing so. Additionally, as your instructor, you're all very nice. I enjoy having you in class. I think the saying goes, I don't want to see you again, which means that I don't want you to fail and come back. Unless you're coming back for historical geology, in that case, I'll see you next semester. But this semester, listen, I want you all to get through this, and I'm going to be sure to give you every tool that I can. All right, moving along. Today, like I said, we're going to be back. We're going to talk about Lab 4, which is igneous rocks. And I'd like you to turn to what's page 40 in your lab manual, I believe. Page 40. Okay. All right. So, igneous rocks. Igneous means fire. Fire. Rocks born in fire. So we can't talk about igneous rocks without talking about volcanoes, because that is where most igneous rocks come from. Okay, so when we talk about igneous rocks, right, we are talking about rock that is formed from molten material. So this means that magma, which is molten material that exists inside the Earth, right, within the Earth itself, finds its way to the surface and becomes lava. And lava is molten rock that is on the surface of the Earth, right? So these rocks find their way, this magma forces its way to the surface, and it eventually turns into, as it cools at various stages of its journey, turns into an igneous rock. Igneous rocks make up the building blocks of many of the rocks on the surface of the planet. We're going to talk about sedimentary rocks for Lab 5. And on the surface of the Earth, on the surface, right, the crust, sedimentary rocks are the most common type of rock. But inside the Earth, it's all igneous. It's all igneous. So the most common element, the most common type of rock on the planet Earth is igneous, but on the surface of our planet, where there is rain, where there is weather, where there is wind, where there's all kinds of things that can break down these rocks, it is sedimentary. And we're going to talk about those also in Lab 5, which I will be posting very soon. All right. So when we talk about volcanoes, we know that I've shown you guys a few times volcanic eruptions. I think I put some up here quite a few times. I find them to be spectacular, so I tend to show them often. So volcanoes erupt because there's such immense pressure that builds up within this magma, right? And what happens is it's a bit like, I did this for my students yesterday when I taught about volcanoes, is I went out to the soda machine out here, got a bottle, I shook it up, and then I opened it. And the process is not the same, but very similar, where I created a lot of pressure within that bottle that the gases needed somewhere to go to escape. It became so intense that the moment I opened that soda bottle, erupted. And the process is very much the same. That these gases are trying desperately to escape, and they have nowhere else to go but up. So, the most common type of gas in magma, this might seem strange because you'd be like, wow, how does this get deep within the earth? Is oxygen. So a lot of the gases driving this process is just made up of simple oxygen. All right. Okay, so that was page 41. I would like to go to page 42, and we're going to start getting into the bulk of this lab. Okay, so igneous rocks. There are two ways I'm going to ask you to identify an igneous rock, right? And that is texture and composition. Those of you at home, I'm really sorry. My handwriting is not, it ain't great. We're getting there. All right. Okay. So the first thing we're going to do is we're going to talk about texture. Texture comes first. So when we talk about texture, we often think of the tactile experience of handling something, right? So the texture of food, the texture of a fabric, a blanket, a rug, right? In this case, we're talking about the individual crystals contained within the rock. That is what we mean by texture. So, for example, there is a difference in texture between this rock right here, you see, right? Interesting colorations and markings, right? And this. There's a difference in texture. We measure this by talking about the crystals in the rock. So the first one we're going to talk about is Phaneritic. Okay. Now, typically when I taught this, I asked the class to repeat this back to me. I'm not going to ask you to do this. But when you hear the word Phaneritic, I want you to think big crystals. Big crystals. Phaneritic, big crystals, every time. When you are taking the midterm, and I guarantee you this will be on it, Phaneritic, big crystals, every time. Make sure you know that going in. But why does it have big crystals? Well, this has to deal with where this rock has cooled. Where this rock has cooled. So this rock right here is Phaneritic. So when we say big crystals, we mean that you can see the individual building blocks that make this one up, right? So various minerals have come together and have compressed themselves into this rock, right? Okay. What that means is that it cooled intrusively, slowly and intrusively. Slowly and intrusively. Now, what intrusive means is that it cooled inside the earth. This rock was formed inside of our planet, not on the surface. Okay? Inversely, we have aphaneritic. And aphaneritic, if we have big crystals, we can talk about small crystals. And since we know that there are opposites here, aphaneritic, phaneritic, right? Since we know these are opposites, it also tells you that this cooled quickly. Cooled quickly and extrusively. So that means that the magma that created this rock, let me find, let's see here. I can promise you this will be a bonus question somewhere. This is Rhyolite. It's my favorite rock. Yeah. So that's why I teach this class, because I'm rock nerd enough to have a favorite. Okay, so this is Rhyolite. Rhyolite is aphanitic. It is aphanitic because it has small crystals that you cannot see. It is too finely textured, which means that it cooled quickly and extrusively. It did not have time for the crystals that created this rock to come together and become visible, like it did with, where'd the gabbro go? Like it did with gabbro, right? As at home, see the difference here? So large crystals, small crystals. Yeah. Okay. All right. So next we're going to talk about, actually before we move on, remember, aphanitic, big crystals. Sorry, phaneritic, got me. Phaneritic, big crystals. Aphanitic, small crystals. Drill that into your head. Make sure you know, when you come to midterm, this is one of the things you need to know, right here. Phaneritic, big crystals. Aphanitic, small crystals. When we have the review, I'm probably going to go through that, and I might say it like 8 more times. So, okay. Next up, turn to page 43. 43 is glassy. Glassy. Right. Okay. So, I think I've talked about this before, but we, if you've watched Game of Thrones, yeah, it's okay. It didn't end well. I'm not judging you guys. Listen. This is what they call dragon glass. It's an apt name. This is obsidian. It's obsidian. Right? Shiny, glassy, which means that it cooled instantaneously because it was exposed to water. So, cooled quickly. When it was exposed to water. So let's have a little thought exercise here. Is this aphanitic or phaneritic? Why? Why would it be aphanitic? Okay, which is very good. And you also cannot see the individual crystals. So yes, you're right. You could classify this as aphanitic. It's glassy, but it still has aphanitic qualities. Okay. All right. So next we're going to talk about porphyritic. Porphyritic. Here it is. All right. So porphyritic. So a porphyritic rock has some very unique characteristics to it. This is a rock that has cooled both inside and outside the earth. So I showed you guys rhyolite, but I'm not sure if those of you at home can see this. This particular sample of rhyolite has these really strange looking dark crystals in it. And what that means is that these particular dark colored crystals in here started to cool inside the earth. But before the rock could come together and form an intrusive rock, it was extruded to the surface of the planet, where it cooled and was surrounded by this aphanitic texture. So porphyritic rocks partially cool inside and partially cool outside. Okay? Partially cool inside, partially outside. I'm really sorry for my terrible handwriting, by the way. All right. Okay. So the last type of texture we're going to talk about is pyroclastic. Pyroclastic. Let's find a piece of scoria. There we go. So pyroclastic literally means fiery chunks. That's what that means. Okay. So what that means is that this rock was tossed out of a volcano as a fiery chunk, and it cooled. But this particular rock can be seen and identified because of something called vesicles. Vesicles, these are air holes within the rock itself. Sometimes from flying through the air, but usually from being ejected from the volcano where it cools. Additionally, we have another pyroclastic rock that many people know called pumice. Pumice is a very popular one. This generally is from some of the foamy stuff that comes out of volcanoes. All right. All right, so pyroclastic. Okay. So before we move on to the next section, before we move on to composition, do you have any questions about texture? Let's review this one more time. Phaneritic, big crystals, cooled inside the earth, intrusive, right? Aphanitic, small crystals, cooled outside the earth, okay? If it's glassy, means it cooled quickly, generally when exposed to water, so because it like flash cools, just like that, okay? And porphyritic, so part of it cooled inside the earth, then it was extruded and cooled the rest of the way. Pyroclastic, fiery chunks. So stuff that's ejected from the volcano in one form or another. All right. Okay. Now let's talk about composition. Composition. Turn to page 45. Nope, 44. I lied. Choose orange. So composition. So other than their texture, composition is a way for you to tell me what is different between this and this. Okay. There are two ways to identify this, but the first is very apparent. It's the color. Okay. So let's start off with the first type of magma. And we're going to talk about felsic. Felsic. So felsic rocks tend to be very light, both in color and weight, because they are high in silicate elements, right, and low in iron elements. So high in silicon, low in iron. Okay. So we talked about specific gravity, and maybe a little bit less dense. Inversely, we have mafic. Mafic rocks. Okay? Mafic rocks tend to be lower in silicates and higher in iron. So now we can actually compare these two. So this piece of basalt right here is a very hefty rock. It is dark in color. It's very dense. Very high in iron content. Okay? Very low in silicate content. Whereas this piece of rhyolite right here tends to be felsic, higher in silicates, and lower in iron content. Okay. Then we have, let's see what rock comes next. Then we have rocks like diorite and andesite. Okay? Diorite and andesite are both. That gives us an intermediate texture. So intermediate is somewhere in between. Somewhere in between. So they tend to alter their physical characteristics. So you will see here I have a piece of andesite, which is a aphanitic intermediate rock, right? Piece of diorite, actually closer to those at home. So an aphanitic, okay, intermediate rock. Why is this intermediate? Well, it's not that dark, it's not that light, especially not that heavy. Also, we have diorite. Diorite is phaneritic. You can see the crystals in between, right? But it's not really one way or the other. It's kind of is. All right. So, any questions about that? Any questions so far about that? So again, the takeaways here are make sure you know your textures and your compositions. For this lab, I'm going to ask you to identify 7 of these. Ask you to identify 7 of these. Okay? And you're going to have to tell me whether they are any one of these textures. And you'll probably have to tell me the composition. I believe they all require that. So, okay, I do want to talk about something else while I have everybody here. I would like you all to turn to page 47 in your lab manual. Page 47. All right. For those of you at home, if you are here from Physical 2, watching this from Physical 2, this does not pertain to you. This does not pertain to physical geography. If you are watching at home and you are here watching the Rock Lab. This is only for geology. This right here, this chart, is an extra credit assignment for you. Okay? So here's what you're going to do. I'm going to give you 2 options, as I understand that we all learn in different ways. I know this. I spent my first year of grad school with the history department, and it's a lot of memorization. It's a lot of committing things to memory, committing various processes and years and dates to memory, right? So I'm going to give those of us who are bad at that, like myself, a way to also do this visually. So the first way you can do the extra credit assignment is to memorize that chart. Come in here. I will put it up here. I will put an empty template up here, and you will fill it out. Every bit of it that you get right, I will give you. I'm not sure how I'm going to do the point scoring yet, but when you get something right, I will give you some extra credit for it. I'm not sure how many points it's going to be worth yet, but we're gonna work on that. The chart will be completely empty. You will have to fill out the Phaneritic through Pyroclastic and so on, Felsic through mafic, and then the rocks. Okay, so that will probably be up on here somewhere. That is the first way you can do this. If it is easier for you to memorize, to commit something to memory and walk in here and write it down, this is for you. That's the way you want to do it. Okay. If you are like myself and you are a visual learner, I am very visual and tactile. I will give you the, 9 rocks from this, and I will ask you to order them. I will ask you to order those rocks. But I will also ask you what they are. You can't just come in here and memorize the order I'm about to show you, because I will show you what the order looks like. You're going to have to tell me what they are. Okay? This is for those of us, again, who are tactile visual learners. I want to give various ways to do this extra credit that both work out. And I will probably, should you do this, the visual route, I will probably ask you a question. Like, hey, is that aphanetic? Is that phaneritic? Just so you know, because those of you who fill it out that have to do it the manual way have to know that to begin with. So, I am going to figure out when to do this. We might do this on, if it is easier for you, those of you at home, if it is easier for you to do this through Teams or Zoom or whichever you prefer, let me know. I'm very flexible with how you want to do this. Those of you who would like to do this in person, you can schedule a time with me to do this if you would like. But probably what I will do is I will have this somewhere. I'm still working out the logistics of how we're going to do it. But I want everybody to have the opportunity. And this needs to happen before the midterm. You might say, well, didn't you just say the midterm was next week? And you'd be right. I did. I did. If you know this, if you know this chart, and you know what this chart means, the aphanitic, phaneritic, porphyritic, pyroclastic, glassy, if you know what this chart means, you have already aced a large portion of the test. You will have already just knocked out of the park a large portion of the test and gotten some extra credit. I'm not asking you to learn this. I'm not going to give you extra credit that doesn't mean anything or lend itself to the material we're teaching. This is something you need to know. If you come back here for historical geology, if you are coming back here next semester for this, and I will see you again because I'll be teaching it, you need to know this. It's not even a question. You're going to have to know this. So, all right. Any questions about the extra credit? Okay. I will be working on the logistics of that today. I'm not entirely sure how we're going to get everyone through that, but I will probably ask you to email me and say, hey, I'd like to attempt it somehow. Tell me if you want to do it in person or virtually. We'll work that out. Okay. I'm leaning towards this being like 10 points. That's half a lab. So I'm leaning towards this being like 10 points. I haven't decided on the point scheme yet, so I'm not particularly married to that, but it is important for you to know this. So, okay. Before I start getting the lab together, remember I will be putting Lab 5 on Canvas. Please take it for the midterm. If you do not have all of your labs in, this is also for those of you watching at home, please hear this. If you do not have all your labs in, you must have them in by the midterm, or they will be a 0. There's nothing I can do beyond that point. After the midterm, I will be a little bit more. Listen, I'm not trying to be strict with everybody and be like, hey, you give me your labs like now. I'm not trying to be like that. I know some people have had to catch up because of the lab annual in the beginning and so on and so forth. The second half of the semester, just for ease of grading, I won't be doing that. But if you have labs to make up, please get them to me before the midterm. I would ask, please be kind to your instructor. Don't turn them in at the midterm because I will have to grade midterms and then also grade the labs. Please have mercy upon my soul. So, do you have any questions? It's looking like it. Heaven, yes, it's looking like it. I need to confirm that because I looked at the academic calendar and it had October 22nd due for midterm dates, but then it's crossed out and it says October 15th, which is the middle of 2 weeks, which means that next week is midterms. So it is looking like that. So this week, going to be a very active week on Canvas for us. So I will put something up about the midterm. I will put something up about the extra credit. I'll put something about Lab 5. And I will also have a study session planned very soon. Do not, and I know this might be like, don't stress the midterm. You guys, you know this. If you feel like you need something extra, some extra reinforcement, please say something. Please email me, please. I know I'm not always great about my emails, but please do so because I will get there. This week is, I'm in high gear this week trying to get it all taken care of. So, all right. Okay, now that I'm done with all this housekeeping stuff, talking about the extra credit, let's get into the lab itself. So what I'm going to do is for those of you at home, I am going to, all right, so we're going to move this. How far can I move this and get away with it? Okay, come on. So, all right. Frustrating. Okay, there's sample A. I will find a way to make these better seen for those of you at home. Sample B. Sample C. What are we going to do? So here one at a time. Take a look at these. I selected these samples. And like I said, one at a time, come up here and take a look at them. on the lab. The rock name is not a necessity. It's not a necessity. But I asked that 1, 2, 3, 4, 5, 6, 7, 2, 14. I asked that you try and at least name like 3 or 4. So, what was rock G? Rock G was this. All right, those of you at home, I'm going to try and turn this so that it better. I know this is twisty. All right. So here is rock samples. Right. All right. So what I'm going to do is I'm going to let the other students who are here come up and take a look at the samples. Okay. And then what I'm going to do is once they're done, I'm going to give those of you at home a closer look at the samples. Actually, let's move this out of the way for right now. So those of you here, come up here, take a look at the samples. Get an idea for what is going on here, and go ahead and start trying to identify them for lab 4. All right. You are free to take pictures. You are free to, however you so choose to do it. Okay. Are you gonna go? Did you want to? Oh, yeah. Okay. I just wanted to before I sit down and take the people at home through it. All right. So let's turn this. Okay. Those of you at home. All right. Here is sample A. Take a look. Notice the color and texture. It's fairly light. All right. Oh, also note any, shall we say, strange markings. Closer. So, yep, it's down, perfect. Okay. Sample B, here's sample B. This color. All right. And the texture, be sure to notice the texture. Remember when we talk about texture, we're talking about the size of crystals, whether it is glassy, porphyritic, or pyroclastic. We talk about composition, we're generally denoting color or weight. I know you can't really talk about weight with you guys being at home, but, well. All right. Okay. Here's sample C. Sample C, take note of this dynamic looking rock. All right. Sample C, notice these vesicles here on the rock. Okay. Is that clear enough? It should be clear. I hope so. All right. Okay. Sample D. Sample D. That. So again, note the texture, which crystal size, and the composition. And for those of you at home, you will be able to determine composition by color. This is sample E. Sample E. So again, crystal size, color. Right. Okay. This is sample F. One thing to note about sample F is that it has vesicles and that it's extremely light. Extremely light. But it has vesicles. This is F. And this is sample G. Sample G. Right. Notice how that catches the light. There we go. Sample G. Okay. All right. If you need to, from here, once the stream is over, which will be very soon, you can go back and you can pause on some of these if you need to. But that is the 7 samples. Right. So we'll turn this to here. So again, take note when you are looking at samples, texture, it's very important. Whether they are large crystals, small crystals, or something else. Okay. And I'm looking at the color. I'll tell you composition. Composition. Okay. I'm going to end the stream here. So those of you at home, if you have any questions, let me know. Again, be on the lookout. There are going to be a few notifications going up in the next couple days since we'll have the extra credit and lab 5, which I will be simplifying a little bit, and I assure you I will be grading them very leniently. All right, so thank you for attending. There are 14 of you. Awesome. Thank you for showing up. And best of luck.